Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever, and we are continuing our discussion, our journey, our exploration of equations of straight lines. This is part number 3. Let's get to it, shall we? All right, so, oops. What do we want to do here? We're going to go to equations from graph. So here we go. This is quite an easy one. We can look at a graph. I shouldn't say it's easy in case you don't think it's easy, because sometimes we don't understand things. That's okay. That's why we have school. So I look at this graph, and what do I have? Well, what I have right here is a y-intercept. And then I have a point. Well, if I have a y-intercept, I am immediately thinking of the form of a line, slope-intercept, gradient-intercept, both the same thing. And I know that b is my y-intercept. So my b is going to be equal to 2. Okay, so then all I need is m. And I got my equation, baby. So if this is the y-intercept, I can think of it as the coordinate 0, 2. So finding the slope is quite easy. y2 minus y1 over x2 minus x1. So that would equal, I'm going to use 3 for y2 and 2 for y1. Again, it doesn't matter. I could have started with the 2 as long as I'm consistent then with my x terms. So let's see, 3 minus 2 over 4 minus 0. And that is equal to 1 over 4. And I am done. That is my gradient. So I just replace those in the slope-intercept form. So replace m with 1/4. So I get 1/4 x plus 2. And there we have it. Let's graph it real quick just to verify. I don't know if I've shown you this before, or maybe you already know it. Great feature on this calculator. If I hit Control and divide, I get a fraction bar. So I can type in 1/4. So I think that's pretty cool. And you can see the little fraction bar icon right above the division symbol. X, and then my y-intercept was 2. And then we can compare it to what we had on our graph here, or that what was given in the question. And looks just about the same there, doesn't it? Let's go ahead and move to the next example. Before I do that, realize that f1 of x, that is just function notation. It's another way to state, to use y. And as we get into functions, you'll see why it's quite important to have that notation. All right, next, find in general form the equation of the line with the graph 1, 2, and 5. All right, so here we don't have a y-intercept, so we're going to use the strategy of using our slope formula twice, but we must first realize this x-intercept here has the coordinate 5, 0, because you would move 5 to the right from the origin and you would not move up or down. So again, we know that slope is given by this wonderful little formula here. And if I'm going to go ahead and use my y2 here as 2 minus 0 over, and since I started here as y2, this 1 must be my x1. We must be consistent. So that's 1 minus 5. So that's going to be equal to 2 over negative 4, and we can simplify that to negative 1/2. Now I'm going to use the slope form again, just a little differently. I'm going to replace the m with what I know it's equal to. Negative 1/2 is equal to, and then instead of y2 and y1, all I need to use at this point is y, and I can choose either one of these points. I think it's always nice to, if there's a 0 as one of the coordinates, it makes life a lot easier. So I'm going to say it's equal to y minus 0 over x minus 5. Okay, and if I clean that up a little bit, I get y minus 0 is y over x minus 5. Then I'm going to do the cross multiply thing, because if they're and did equal, their cross products must be equal. And it doesn't matter which diagonal you use, so I'm going to go ahead and do this diagonal first. I should say it doesn't matter which diagonal you do first. So 2 times y is 2y, and that is going to equal negative 1 multiplied by x minus 5. And please do not forget these parentheses. They are extremely important because it reminds us that we must distribute the coefficient here. So we clean up a little bit. 2y equals negative x minus 5. Stay tuned on that one. And they want it in general form. So I'm going to add x to both sides. And I end up with x plus 2y equals negative 5. Now, from here, well, I did that just because they requested general form, but I also want to graph it to show you we get the same graph. So from here, I'm going to rewrite this step, and I'm going to put it in gradient intercept form so we can easily graph it. I'm going to divide everything by 2, and kapow, and then I get y equals negative x over 2 is the same as negative 1/2 x minus 5/2. Let's go ahead and graph that, negative 1/2 x. And here's the nice little feature, by the way. You can double click and then you don't have to have as much editing. So that was negative 1/2, and I just got to change that 4 to a 2. I forget the y-intercept. It's minus 5/2. So I can highlight that, change it to minus 5/2. Boom. And there we go. Let's see how it matches. And there I have it. Let's make it a little smaller so it doesn't block the writing. And you can see it is indeed the same line. Okay. Last one. Find the equation connecting the variables in this line. Now notice they say connecting the variables. They've changed them. And a lot of times we'll want to do that because we'll want to use letters that make sense for whatever it is that we're studying. If you don't like that, you can certainly go ahead and use x and y and then just replace them with n and p respectively. So again, we have a situation where we have the y-intercept, and that has the coordinate 0, 3. So whenever that occurs, I'm going straight to y equals mx plus b, because I immediately know that my b is equal to 3, and all I need now is the slope. So I'll use these 2 points to find the slope. Again, m equals y2 minus y1 over x2 minus x1, which is equal to, I'm going to use my y2 as 3. So that's 3 minus 2 over 0 minus 5. That's equal to 1 over negative 5, which we can think of as negative 1/5. And then I just have to replace my slope with the negative 1/5 and the y-intercept b with 3, and I've got my equation. So y equals negative 1/5 x plus 3. Let's go ahead and test that one out with our graphing calculator. Again, I'll just change this, negative 1/5 x. Let's see. So I change that to a 5. I already have my negative plus 3. I can highlight that and just quickly do plus 3. And there we go. I believe it's the same. Let's copy it, put it right in there, and looks like the same line to me. All right, well, hope you enjoyed it. I know that I did. Let's see what we got playing here. Oh, we got the beginning of Sweet Talking Woman, one of my favorite songs. I hope you enjoyed our short time together. I'll be back, so will you. I am out! I was searching on a one-way street. I was hoping for a chance to meet. I was waiting.